Doing some exercises here. What ordered pairs make the expression true? Worksheet. And actually, the name of this worksheet should be true or false. Let's read the directions really closely here. The question is actually to figure out which ordered pairs for A and B make the following expressions false. So in this case, number one, let's simplify the expression as much as we can using Boolean identities that you learned before this worksheet. So this given expression could be simplified using De Morgan's law. We could distribute this not to the A term and over here to the not B term. By writing the not against both of those small expressions, we write that, but this and must be changed to an or. So that broke up those parentheses. And the outer parentheses are still there. The outer parentheses in the problem are still there. I did add a set of parentheses when I distributed the not over to this term. So I carefully put a set of parentheses there. Anyway, the next exercise, or the next step, I'm going to work on this right-hand side, rewriting the left-hand side here, not A, and rewriting the or. I can use one of my identities to simplify the not B. The nots cancel out, and that leaves just the B term. I still have my outer set of parentheses. Next step. There is no next step. There's no identity that allows you to break this up further. So we've now simplified the given expression as far as we can. We don't need the outer parentheses, so I'm just going to rewrite this in the simplest format possible. Now, reading the question closely, what ordered pairs, A and B, make the following expression false? There are four possible ordered pairs. I always like to list them 0, 0, 0, 1, 1, 0, and 1, 1 in that order. We could manually plug those in, or we could just think it out. Let's do some thinking it out. To make this overall expression true, because it has an or, anytime B is true, that makes the whole expression true because or allows either side to be true to make the whole thing true. So for all cases here, in all possible ordered pairs, where this column here, B, is a true, and I use a 1 is equal to true, and a 0 is false. That's just my habit and convention on worksheets like this and doing exercises in Boolean algebra. So on the right-hand column here, both of these ordered pairs will make the whole thing true. And for the other two situations, 0, 0, and 1, 0, I can just plug those in manually and think it out. If I plugged zeros in for both A and B, I would have not 0 ORed with a 0. And the not of a 0 simplifies to a true, a 1, and I'm left with the or 0. And in that case, it simplifies to 1. So this case does indeed work with a 0 and a 0 plugged in. And I have one more ordered pair to test, and that would be the ordered pair over here that's not checked off yet, 1, 0. So by plugging a 1, 0 in for the A and B and rewriting everything else just to be have a nice style here, since I have time to do this, I'm not in a rush on an actual exam. The not of 1 simplifies to a false ORed with a false according to a truth table that you could learn about elsewhere, or just know that anytime you have a false ORed with a false, overall it's false. So this ordered pair does not work. And they are asking what ordered pairs make the following expression false. Well, when I say works, actually, this case is the one that, according to the directions of asking for false, that's the one and only case that I should write as an answer here. Because all the other evaluations I was doing, I was evaluating to see what makes it true. And by reading the directions carefully, it's, the answer should be written as 1, 0, parentheses around it, is the only ordered pair for A and B in that order that makes this original expression false because of the directions. That is the answer. Exercise 2, I'm going to simplify this as far as I can using Boolean identities. I'm going to use De Morgan's law here on this left-hand side of the and. And I'm going to switch to another notation to make this simpler to write out, just showing you in this video a taste of how you could use the tilde as a not operator. And you could use plus for addition. So I'm taking a whole step here. And the and is, you could either use an asterisk, or you could just sort of put sets of parentheses or operators next to each other. I slipped back into the other notation there by accident. So by being consistent here and using this other notation that's very common in Boolean algebra, especially on ACSL materials that you might be looking at and reviewing. So now I can start applying my Boolean identities with a more compact notation. The not here distributes to throughout this parentheses using De Morgan's law. So that's the not of not A. This plus changes to a multiplication. That not distributes over here to this B, just like it distributed here to the A. I still have my outer set of parentheses. I don't want to lose those. That parenthesis matched this parenthesis, so I repeat them. The star is still there, multiplication. Over here on the right-hand side, I have a De Morgan's law that I need to apply also. So this outer set of parentheses needs to be written down, but that not applies to the A. Distributes. That plus changes to multiplication, or and, the and Boolean and operation. And we have two nots now over here next to the B, because that not distributed over here in front of the existing not. Okay, the next step. These two knots cancel out, leaving just an A. The not B, I don't need it to use the star. I could just write it this way. That shows multiplication. It's A times not B. I still have my outer parentheses here. And this part right here, times not B, I'm going to drop the asterisk for multiplication right now. So I have this simplification on this left-hand side. This asterisk, I can drop it and just leave all of this in a set of parentheses here. Not A times, well, these two nots cancel out, so that's really a B, and this not A doesn't change at all, so all of this simplifies to just this expression. And one more step. Anytime you have a not B times a not B, that simplifies to just one not B, according to a Boolean identity. I'm rewriting the A. And since everything else is multiplication, there's no addition or, so I don't need any parentheses. I can just write this all compactly like this, moving everything over like this. So, okay, with some associativity, I can rearrange this according to Boolean identities as A times not A, and then not B times B. I noticed that anytime you have an operand times it's the negation of itself, one or the other of those has to be a zero. And so according to a Boolean identity, this is just simplifies to 0. The same over here, that simplifies to 0. These are being multiplied because of they're written next to each other. So 0 times 0 simplifies to 0, and that should be written as a false on ACSL exercises, not as a 0 for these Boolean algebra exercises. So no matter what plugs in, no matter what ordered pairs plug in for A and B, it doesn't matter, because according to this simplification of all these steps, this expression always ends up being false. All of these evaluate to false. And exercise 3. Switching notation here, like I did before, being careful to make sure I keep the parentheses as is. And adding parentheses where I need to. I forgot, I'm not using the word not, I'm using a tilde. Okay, so there is the rewritten expression with those symbols. Working from inside the parentheses out, A distributes to this A and this B. So that would be AA plus AB. That is not De Morgan's law, because A is not a negative sign. So all of that has a tilde around it. And we have another set of parentheses here to preserve that left side and rewrite it correctly. Now on the right side here, this plus. They can be written like so. With technically, I don't need the parentheses anymore to be safe. And the next step, these A's consolidate to be just one A by one of our identities. So that was a simplification I can make in this nice little step. And my next step. Keep in mind that the order of operations, this multiplication here, must be done before this plus. If you want to, you could have, to be safe, kept a set of parentheses around all that. Okay, this next step. I can factor out this A. And also, don't simplify the two negations. Don't cancel them out. You can't do that right now because of the larger sets of parentheses. So I'm inside here, I'm factoring out an A, and then that turns out to be A times the quantity 1 plus B. So that is by one of our identities, or the reverse of one of our identities. Rewriting this right-hand side. This next step, again, working inside the parentheses, when you have 1 plus B, a true ORed with anything is always going to be true. So this is simply a 1, and I'm left with A times 1. Again, just tediously but carefully rewriting everything out to show each little step, since I don't have to rush. I'm not taking an exam right now. Right here, anything times 1 is the operand itself. And this left-hand side now is simplified to that. And these knots cancel out, so I'm left with A there plus B times not A. Continuing over here, I can't do anything here. I'm just going to rewrite this in its simplest form. You cannot factor out an A here because this is a not A. And the question was, what ordered pairs make this equal to false? So let's think about it. First, I'm just going to think about it as what ordered pairs make it true, because I'm more used to doing that. Well, because of that or, when A is true, it's always going to be true, the whole expression. So these two ones make that whole expression true. In the case of this right-hand side, even if the A is false, if we have 0 and 0, that would be 0 times the naught of a 0 would be a 1. And that cancels out the 0, and we would have 0 plus 0. So this substitution does not make the whole thing true. That makes the expression false. These were both trues. Let's use t's there and f there. Okay, the 0 and the 1. Plugging the 0 and the 1 in for this the a and the b respectively, we see, I'm going to use green here, plugging a 0 for all the a's and a 1 for the b, putting my naught and my or there. That simplifies to 0 plus, well, 1 times the opposite of 0 is 1. This right-hand side simplifies to 1. We have a 0. That whole thing simplifies to true. So this is a t. But because the original question asked for ordered pairs that make this whole expression false, the only ordered pair that does that is 0, 0. So the answer, I think I messed up on the writing the answer for the last exercise. So anyway, the answer down here is 0, 0. And you see how easy it is to make an error by not following the directions closely on an ACSL exercise. This answer was wrong. False is not what they're asking for in this worded question. It was which ordered pairs make the expression false. So all 4 ordered pairs apparently make it false, and I would have to list them. Now, it doesn't matter what order you list them, as long as you list all 4 of them, it would be graded or marked correct. So fitting all 4 of them on the line. Unfortunately, even if you had scratch work that showed knowledge, because of the way the ACSL exam is strictly graded, you would have to put the answer in the correct format. Okay, there are the answers to that worksheet. And we were actually, checking for false, whether the title of that worksheet is currently true or not. You always read the directions.